Experiment's name is Newton's bottle dollar bill inertia trick. It is based off of Newton's first law of motion, which is inertia. My subpoints are going to be force, kinetic energy, momentum, and velocity. My main point for the project is Newton's first law, which is stating inertia. An object at rest stays at rest. An object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. A subpoint is force. An interaction, when unopposed, will change the motion of an object. Therefore, stating force can cause an object with mass to change its velocity to accelerate. Another subpoint is kinetic energy. Energy that a body possesses by virtue of being in motion. Another subpoint is velocity, which is a vector quantity that is both magnitude and direction are needed to define it. Another subpoint is momentum. This is the product of mass and velocity of an object. Here we have one of my subpoints, which is force. Right here we have our XY diagram that basically has information from the given and the unknown. Our given is mass equals 180 grams and acceleration, which is 2.0 meters per second. Our unknown is force. Our equation is force equals mass times acceleration. And then for our substitution that's next, we need to change the grams into kilograms. So the fact is 1 kilogram equals 1,000 grams. So we did the math for it, which is we divided it 180 by 1,000 and we got 0.18 kilograms. So next we plug in that into the force equation and we got 0.36 kilograms times meters squared. And our solution is force equals 0.36 kilograms times divided by seconds squared. Okay, here we have one of our subpoints, which is velocity. Here we have our XY diagram, which basically has the information from the given and the unknown. In our given, we have the displacement, which is 0.179 meters. And our time is 0.3 seconds. And our known is what we're trying to find is velocity. The equation to find velocity is delta x divided by delta t. So we substitute that into the equation 0.179 meters divided by 0.3 seconds and we get velocity equals 0.5966 meters squared. So we round that to our nearest sig fig because we only need one, and that is 0.6. Our solution is velocity equals 0.6 meters squared. Okay, here we have another one of our subpoints, which is kinetic energy. This is the XY diagram where we have all the given and the unknown information. In the given, we are given mass, which is 180 grams, and velocity, which is 0.600 meters squared. We are trying to find kinetic energy, so the equation we're going to use is kinetic energy equals 1/2 times mass times velocity squared. For the substitution, we're going to change our grams to kilograms, and with that, we're going to divide 180 by 1,000. We get 0.18 grams. So we plug that new number into the kinetic energy equation and we get 0.0324 kilogram meters squared divided by second squared. And since we only have to have one sig figure, we rounded it off to 0.0300 kilograms times meters squared divided by second squared. And then we're also going to change our fact from 1 joule equals 1 kilogram times meter squared divided by second squared. So our solution is kinetic energy equals 0.0300 joules. Here we have momentum. In our XY diagram, we have the information that is given and also the unknown. What is given is the mass, which is 180 grams, and the velocity, which is 0.600 meters divided by seconds. The unknown is momentum, and the equation to find momentum is mass times velocity. Next, we're going to move on to our substitution, which is we're going to change the grams into kilograms. By dividing 180 by 1,000, we get 0.18 kilograms. We plug that into our momentum equation and we get 0.108 kilograms meters squared divided by seconds. Our solution is momentum equals 0.108 kilograms meter times mass squared divided by seconds.